Welcome to the DIY Honda Garage channel. DTC P0723, which stands for Output Shaft Countershaft Speed Sensor Intermittent Failure, indicates an issue with the electrical circuit related to the output shaft speed sensor, located in the automatic transmission. This problem is specific to Honda Civic models from 2011 to 2015 and is not caused by mechanical issues within the transmission itself, making it purely a diagnostic electrical concern. The output shaft speed sensor plays a crucial role in the vehicle's transmission system by monitoring the rotational speed of the output shaft or countershaft and communicating this data to the Powertrain Control Module, PCM. This input is vital for managing gear shifts and overall transmission performance. Furthermore, the transmission's overall functionality can be compromised if this sensor malfunctions, leading to undesired driving characteristics and potential transmission damage. Proper diagnostic steps must be taken to ensure accurate identification of the issue to avoid unnecessary repairs. The output shaft speed sensor, often termed the countershaft speed sensor, directly measures the speed of the output shaft in the automatic transmission of the Honda Civic. This sensor is typically located on the side of the transmission case, close to the output side, allowing it to accurately gauge the rotational speed as the vehicle operates. Its primary role is to send speed data to the PCM, which is essential for optimal operation of the vehicle's automatic transmission system. The PCM utilizes this information to facilitate proper shifting patterns and maintain performance efficiency. If this sensor fails or experiences intermittent electrical issues, it can result in poor shifting behavior, a loss of power, or even failure to switch gears effectively. Understanding the importance of this sensor helps technicians diagnose DTC P0723 and rectify issues related to transmission efficiency swiftly. The primary cause of DTC P0723 lies within the electrical circuit linked to the output shaft speed sensor. This DTC indicates that the sensor is experiencing an intermittent failure, primarily due to electrical issues rather than mechanical problems. One common reason could be an open wire in the VCC1 circuit, which feeds voltage to the sensor. Additionally, a faulty output shaft speed sensor could also contribute to this DTC if it fails to provide accurate readings. Voltage measurements are crucial in identifying these issues, as they help confirm whether the circuit is functioning correctly. Proper troubleshooting is essential to isolate the exact cause of the failure and to make necessary repairs before the issue escalates any further. When DTC P0723 presents itself, several symptoms may arise, significantly affecting the vehicle's operation. The most noticeable symptom is that the transmission may exhibit erratic shifting behavior, leading to harsh or delayed gear shifts. This can result in an overall poor driving experience, where the engine may feel unresponsive or sluggish. Additionally, drivers might notice increased fuel consumption, since the transmission may not be optimizing gear shifts effectively, causing the engine to work harder than necessary. Dashboard warning lights could illuminate, indicating to the driver that there is a problem that needs attention. These symptoms collectively signal that the input sent by the output shaft speed sensor is not being processed accurately by the PCM, prompting immediate diagnostic action to address the DTC. The first step in troubleshooting DTC P0723 involves verifying the problem before proceeding with in-depth diagnostics. Begin by turning the ignition switch to the on position, but do not start the engine just yet. Following that, use the Honda Diagnostics System, HDS, to clear the DTC from the system memory to ensure any previous faults are not influencing the current diagnostic process. Next, raise the front of the vehicle securely, ensuring that it is properly supported with jack stands or on a lift, to allow for safe wheel rotation during testing. By blocking the rear wheels, you ensure that the front wheels can rotate freely, enabling accurate measurement of speeds during the next phases of diagnosis. Once this setup is complete, you will initiate a test drive with specific parameters to assess the performance of the speed sensor. Moving into the second troubleshooting step, disconnect the output shaft countershaft speed sensor 3P connector, as it is crucial for isolating the issue. Before proceeding, ensure the ignition switch is turned to lock 0 for safety. Once the sensor is disconnected, turn the ignition switch back to the on 2 position. With the sensor disconnected, employ a multimeter to measure the voltage at specific test points on the sensor connector. You should check the voltage between test point 1 and test point 2, where test point 1 corresponds to the yellow/red wire of the sensor, and test point 2 is connected to the body ground. If the measured voltage is around 5 volts, this indicates the VCC1 wire is intact, allowing you to move forward in troubleshooting. If the voltage is not present, repairs will be necessary to address the open circuit. Next, in step 3, you will begin checking the possible failure area related to the output shaft speed sensor. First, ensure the ignition switch remains in the on position and keep the output shaft countershaft speed sensor 3P connector disconnected. Your goal here is to measure the voltage on the NC line, which is the black-white wire in the connector. Connect your multimeter to test points 1 and 2 to assess the voltage output. Again, if you measure approximately 5 volts, this indicates the circuit is functioning correctly, allowing you to move to the next troubleshooting step. However, if the voltage level is below this threshold, it signifies a problem in the NC line, leading you to step 5 for further checks. In troubleshooting step 4, attention shifts to the SG1 line, which is the green-white wire responsible for transmitting signals from the sensor to the PCM. Begin by ensuring the ignition switch is in the lock 0 position, and like before, keep the output shaft countershaft speed sensor connector disconnected. You will now check for continuity between test points 1 and 2. Test point 1 corresponds with the SG1 line, while test point 2 connects to body ground. If continuity exists, this indicates that the SG1 wire is functioning correctly, leading you to replace the output shaft speed sensor as the next step. Conversely, if no continuity is found, it implies an open circuit in the SG1 wire, necessitating repairs to the wiring before moving on to the next step. The final troubleshooting step for DTC P0723 involves checking the NC line for shorts and continuity. To begin, you will temporarily jump the SCS line using the HDS to safely perform the continuity check. Make sure the ignition switch is in the lock 0 position before disconnecting the PCM connector B49P, as this will affect your measurements. With the output shaft, countershaft, speed sensor connector disconnected, check for continuity between test points 1 and 2, where test point 1 connects to NC line and test point 2 is body ground. If continuity is confirmed, it indicates a short to ground in the NC wire that requires repair. On the other hand, if continuity does not exist, this suggests that the NC wire is not shorted, and therefore, any open issues along this wire must be addressed before proceeding to finalize repairs. After completing the necessary repairs based on the previous troubleshooting steps, it's essential to verify that the DTC P0723 has been resolved effectively. Begin by carefully reconnecting all connectors that were previously disconnected during the troubleshooting process, ensuring secure connections. Then proceed to clear the DTC using the Honda Diagnostics system HDS to reset any stored error codes. Once this is accomplished, start the engine and disable the Vehicle Stability Assist (VSA) system by pressing the VSA off button. Take the vehicle out for a test drive with the gear selector in drive, D, and maintain speeds over 12 miles per hour, 20 kilometers per hour, while monitoring the AT data list via the HDS. If the input shaft, main shaft, speed, and the output shaft, countershaft, speed are now aligned during your test, it indicates that the system is functioning correctly and the issue has been resolved, marking the end of the troubleshooting process. Though this guide primarily focuses on troubleshooting DTC P0723, incorporating preventive maintenance practices can significantly reduce the likelihood of future issues arising from the output shaft speed sensor. Scheduling regular diagnostic checks can help identify problems before they develop into more significant issues, allowing for timely repairs and minimizing maintenance costs over time. Monitoring the vehicle's performance habits also provides early warnings of irregularities, such as delayed shifting or reduced transmission responsiveness, enabling proactive attention. Additionally, educating vehicle owners about the importance of immediate repairs for any indicated dashboard warning lights can prevent complications later on. Replacing worn or faulty components before they fail completely will keep the transmission operating at peak performance, ensuring the longevity of both the sensor itself and the overall transmission system. In summary, DTC P0723 points to an intermittent failure of the output shaft speed sensor due to issues primarily within the electrical circuits rather than mechanical faults. Correctly diagnosing this DTC emphasizes the significance of electrical connections and circuitry integrity within the vehicle's transmission system. Following the outlined troubleshooting steps allows technicians to pinpoint the exact issue efficiently, addressing open circuits or shorts as necessary. Furthermore, by implementing preventive maintenance strategies, the likelihood of such faults arising can be minimized, ensuring smooth and reliable vehicle operation. Understanding the crucial role of the output shaft speed sensor and promptly addressing any DTCs ensures that your Honda Civic from 2011 to 2015 continues to deliver optimal performance for years to come. Please like and subscribe to the channel. See you next time.